Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. Today we are going to talk about how you can perform ACID transaction in Amazon Athena using Apache Iceberg tables. So let's get started. So first let's try to understand what exactly is ACID transaction and then we'll see how we can achieve ACID transactions in Athena, and especially we'll talk about how to use Iceberg tables to leverage ACID transaction features in Athena. So when we talk about ACID transaction, basically we are talking about how multiple concurrent users can update data in a S3 bucket, but in an atomic manner, so in a consistent fashion. And when we are talking about updating the data, we are not talking about updating the data at the object level, at the file level. We are talking about updating the data at the row level. So we all know that we can store our data inside S3 bucket, and then we can catalog our data in a tabular format in Glue catalog. And post that Glue catalog, actually with ACID transaction, you can actually perform row level modification, row level updates on that catalog table, and that will actually change row level data in S3 bucket. So basically you can do row level modification of your data in S3 bucket, not at the file or the object level. That's very important. And the last one, when you try to perform the operations for row level modification, of course, other than query, you can also write data, you can delete data, you can update a row. And when I say write, delete, update, again, I'm talking about the row level. And you can also make a time travel operations. So whenever you update the data, it creates a snapshot of the data. And using that snapshotting of the data, you can actually go back to any of the past snapshot of the data and say, hey, give me data at day before yesterday, 9 p.m. And let me make query on the data available at in the snapshot available at that point of time. So that kind of time travel query also you can perform using ACID transaction. Now, in Athena, ACID transactions can be achieved using two methods. One is governed table, and second is using Iceberg table. Now, governed table is something which I have covered already in my another tutorial, and I'm going to provide you a link to that tutorial in the description box. But today we are going to talk about Iceberg table. Because this is a new capability, new feature which has been added into Athena. Athena now supports Iceberg tables in order to support ACID transactions. This feature right now is under preview, but it's very interesting for you to learn how exactly it works. So just to give you a very brief introduction about Apache Iceberg, few important things to know about Apache Iceberg. First, it is in an open source table format, which is actually used for analytics on very large size data sets. And basically you can configure your file as tables, and then on those tables you can perform row level or record level operations such as insert, update, delete, or even time travel or snapshot based queries. This table which you create, you can actually evolve. You can evolve based on partition. You can also change the schema in terms of adding, removing, or updating the columns. And Iceberg table, since it supports atomic transactions or ACID transactions, actually this assures the data correctness, especially if you have multiple concurrent write operations happening on your data. Okay, so these are some of the key features of Apache Iceberg, and you can now configure Apache Iceberg based table in S3 bucket using Athena, and then you can use Athena to perform ACID transactions on that. So let's see how exactly it works. So there are a couple of steps involved, but pretty straightforward and simple topic. So let's see how exactly it works. So there are primarily three services which come together. Athena as your query editor, and it can also be used for API based call, by the way. I'm going to show you later. Then S3 is used for your storage, and your glue data catalog is used for cataloging the data. So first step you need to do, you need to have an S3 bucket where you like to keep your data. So you need to have an S3 bucket. Then you create a special work group in Athena, and this work group is called Amazon Athena Iceberg Preview. I understand this might be a temporary requirement because right now this feature is under preview, but you have to keep an eye on the documentation, how the requirement changes. But as of today, you have to create a special work group in Athena, Amazon Athena Iceberg Preview, and under this work group, you have to perform any Iceberg related query, Iceberg tables related queries. So second step is once you have created your S3 bucket, you create a work group in Amazon Athena, and then you create your table. And when you create a table, basically you create a table in Amazon Athena, and I will show you syntax and all those things at later point of time. It's pretty straightforward, to be honest. Nothing different from what, if you have created table using S3 data in Athena, it's not going to be much different from that. Few small changes. But yeah, you create an Iceberg table in Amazon Athena. And when you do that, actually, basically, it updates other two services. So in glue catalog, you will create a table catalog created, and then in S3 bucket, under this bucket, you will have a table manifest created. And this table manifest, you can see actually at what location your table has been created, what is the schema of the table, and also keeps information about where is your partition information, your data location information, all those things you will see in table manifest. This table manifest actually evolves as and when you update the table, because this table manifest is used to also keep the information about your data changes, your schema changes, so that you can make any kind of time travel query to go in the past snapshot of the data and make query out of it. And I'm going to show you some of those examples, so it will start making much more sense when you see that in action. So once you have created a table, actually, then you can start creating the data, updating the data. So as you can see, you can do row level or record level performance. So you can create your record, you can update your record, you can delete your record. And when you do that, actually, what happens in S3 bucket is that your data gets created. So your data files will start getting created, and it will create based on the partition information you have provided. And if you have not created any partition, you have not provided any partition, it does some of its automatic partition just to keep data partitioned. Okay, just to keep data not accumulated at one place, and then it also updates your table manifest to see how data has updated, so that you can always make a time travel query about your data. And of course, you can also query your data in Athena. You can query data in Athena console, or you can also query your data using APIs. And I'm going to show you both of the examples. So that's basically how it's going to work. That's a 4-step process to have your table in place and your data being ready. So let's try to see some of the specifications. So first one is, how do you create the table? It's not different from, like I said, it's not different from how you have been creating tables so far. In Athena, for the S3 based data, you simply use a syntax like this. You simply say create a table, then your table name, then you provide your column name and data types. Then you also provide any partition information or which column you want to partition. This is optional, of course, and if you don't put any partition, it does some of its automatic partition. I'll show you. In fact, I'm not going to use partition in my example, and I'll show you how it partitions. Then you provide the location information where your data will be stored, and then here comes some specifications where you say you have to add some table properties to let the glue know, let Athena know that this is not a normal table, but this is an Iceberg table. So you simply provide some table type, key, and value is Iceberg. And by this key value pair, actually Athena knows, S3 bucket glue knows that this is a special Iceberg table. Pretty straightforward, and you can also provide some more other properties like your how your data should be compressed, how what should be your data file size. All those things also you can provide. So just to see an example, here I'm saying that I want to create a table named Iceberg underscore table. These are my column specifications. I want to partition based on the category and also based on the bucket ID. You can do that as well. Then you are providing the location information, then you're providing some table properties like table type is Iceberg, format is Parquet, the data format is Parquet, and this is what is saying how does your file size byte look like. By the way, it's very important for you to understand, since the solution is this feature is currently in preview. It currently supports only Parquet format, so you cannot have any JSON or CSV based data. Your data format is only Parquet. The supported data format is only Parquet at this point of time. So, having understood the creation part, let's see how you can update the table schema and what all you can update in table schema. So in table schema, you can you see certain table properties like compressed and format and the file size. Those properties you can actually set or unset. You can reorder your column sequence, and you can also actually do typical data DDL operation like add, drop, rename, or update the columns. So few examples here. What we are doing is we are setting up some table properties where we are saying that this data should be compressed using ggzip, and then we are saying my compact target file location byte size should be this. This is the maximum size of the file which should be created actually. So we are setting up some property. Here is example where I'm unsetting some property. For instance, I'm unsetting some value set for the file size. Here is the example where I'm using alter table to actually add a new column of comment which is string type. So these kind of operations you can perform. So once you have created a table, you have to not to live with that, stick with that. If you want, you can change the properties of the table, or you can also change the schema of the table. So how do you update table? So as I said, you can use row label, insert, update, and delete operation using SQL. So it's, to be honest, it's pretty straightforward. It's like a SQL, any SQL you're running. So you are insert into table, then values, or insert into table from another table, or you're updating a column based on certain category, or you're deleting a table. Yeah, why? I don't know why there's a where clause in delete from. Oh yeah, this is deleting the record, not dropping that record. Sorry, I got confused with drop and delete. Yeah, so I'm deleting record based on certain category. So you can create this kind of actually insert, update, and delete operation row wise. You can see in this example using the normal SQL queries you make on any table. Moving on, how do you query your table? So query on the data can happen in two ways. You can query on the current data set. So what is the current data set? You can make query on that, and for that you can simply use select star from table and then use your where clause, whatever you want to do. You can do that way, but you can also make a time or version based query. That means you're not querying for the current data, but you're querying for your previous data. So keep this in mind that when you're creating a Iceberg table, your data is actually immutable. So when you modify the data, it simply creates a new version or new snapshot of data for you. And by virtue of that, actually you can go back to the past data and then you can make query out of it. And that also gives you opportunity to actually do things like rollback and so on. So let's see the first query, which is very interesting one, which tells you that, okay, if I have a table and I need to know what has been different, update history to this table. And I can make a query like select star from, then your table name, and then $, and then Iceberg underscore history. If I make a query like this, it tells me the history of data changes in my table. So you can see here, it shows me this table outcome like this, where you can see these are the snapshot ID. So each time the table is modified, it gets a snapshot ID. Before a new version is created, each version gets a snapshot ID, in fact. This is the date or time when the snapshot was created, when the data was modified, and also shows a parental relationship, that okay, this was the first data, then the next data came, then the next data came. That kind of parental information or snapshot transition information is also showed as a part of the data. So these three are very important column for you to understand. So now if you want to make a query, you can have query like this. So like for instance, in this one I'm saying I want to select data from the table, but I want to get data from the snapshot from the snapshot which was available at 01/01/2020 10 a.m. So at that point of time, what was the current data set available at that point of time in history? Give me data from that table. So that's one example. You can make query like this as well, where you can go current timestamp minus interval a day, or 2 days or 3 days, like that. You can make query like that as well. So I want to see state of the data 1 month before the current date. That kind of a current timestamp, and that kind of query also you can make. Or you can also make a query based on the snapshot. So you can see that snapshot ID, these IDs over here. You can simply provide that system version or snapshot number, and then based on the snapshot ID, you can also make query from the table. So you can see based on the time or based on the version or snapshot, you can actually go to the historical life of the data, and you can make time travel. And at least in data, you can make time travel, not in real life. And you can go and see the previous state of the data, how it has been modified at that point of time. So that was how you can make a time travel or version-based query on the data. You can also, of course, you're using Athena to query data or making update to data. So you can also use Athena APIs, and this could be very important if you're trying to build some application which is trying to use this application, or if you want to use this kind of operations in your ETL, or any kind of other automation job, then you might want to any kind of data job, you can use this kind of API calls there. I have to still explore if I can use data wranglers with these tables, but that's something I will leave it to you to explore, if you can use data wranglers with these tables, because then it will be a fantastic way to manipulate data in your ETL job operation. Like you're writing a glue job and you want to manipulate data in that, then using data wrangler to manipulate an Iceberg table would be a very interesting one to show. I could not get chance to explore it, but I leave it to you if you want to explore that part. And please write that in my comment section whether you have been successful or not. And if you struggle, let me know. I will make up some time and I will try to explore to see if data wranglers can work, data wrangler API can work with Iceberg. Okay, so just to give you an idea about how you can use Athena APIs, you can simply import Boto3. I'm using Python as an example. Then I'm creating a client for Athena. Then I simply set certain parameters, like which query I want to run. In this case, I'm trying to get data from a users table. This is my database name. This is my catalog name. I have to change the work group because I cannot use primary at this point of time. We have to use this Amazon Athena Iceberg preview, and then I'm giving the output location. And then here we go, we simply run this start query execution, where I simply provide my query, my database, my catalog, my output location, and my workgroup information, and this will simply run this query again my table. So right now I'm showing example of a select where I'll get a result back, but you can also use this method to do any kind of insert, delete, or update operation. So that's how you can use Amazon Athena APIs, which primarily you will use if you're trying to build an application on top of this data, or you want to use this in any kind of you want to use this in any kind of job, automated job to transform your data. Okay, so moving on, a few consideration which is very important for you to understand. First, your Athena data type and Iceberg data type, you need to check the compatibility between them. So it doesn't look any it doesn't look any scary here, but it's worth checking that if something is Boolean in Iceberg, it's Boolean in Athena, but something is long in Iceberg, but that is a big integer in Athena. That kind of changes you have to be aware of when you're trying to create a table in Athena for Iceberg. So you need to check this the data type compatibility. Again, it's not a scary part. And then, well, nothing is scary in fact. Currently, this service, this feature is under preview. And right now it's available in North Virginia, Oregon, and Ireland. It's not, but once it comes out of preview, it becomes generally available, then it will be available. And they will, in fact, we have to see documentation which all regions is rolled out. Right now it supports only Parquet file format. Right now the data file you create is created in a Parquet format. And other formats are not supported. Specification wise, it uses Iceberg v2 table specification. So especially if someone is moving, someone is using Iceberg and they want to move to using Athena or S3, then it's a good information for them that it uses Iceberg v2 specification. And right now you have to create an Amazon Athena Iceberg preview work group in order to use these tables from Athena. So few consideration, important one for you to understand. Then time for a demo, where we are going to simply create a table inside S3 bucket, and then we'll simply try to manipulate data and see how it changes beneath the hood. Okay, so let's get started with a demo. So here I am in AWS Management Console. First, let me show you the S3 bucket. So I have got this Dojo My Data, user data, and this is the S3 bucket which I'm going to use for my data location. So right now you can see it is empty. Then this is my Glue console where I have got this database, but it's fine. I'm going to create one more database, and then I will try to manipulate. I will create catalog of the data, and then I will try to manipulate data into that. And here is my Athena, which I'm a console which I'm going to run all the queries. I have also created one Athena client using the code which I'm going to run towards the end to show you how you can use API based call to the Athena to query the Iceberg based data. So first thing first, so we need to first create a Glue database. So I'll simply come over here and say, hey, this is my Dojo DB. This is my database. So this is the database I'm going to use for my Iceberg based table. And then what I'm going to do, I'm going to Athena, and I'm going to create actually a new work group. Because right now it has only primary, but as you know that you need to create a special work group at this point of time in order to use your Iceberg table. So I simply go to the left hand side menu, go to the work groups. I want to create a work group, and I simply call this work group Amazon Athena Iceberg Preview. I will keep the rest of the configuration default. I'm not going to touch anything, and I simply create the work group. So now my work group is created. If I go back to my query editor, and need to change my work group to Amazon Athena Iceberg preview. There we go. Okay. So let me see. I have something. Okay, let's remove these things. Fair enough. So so now we are all good. So we have got our S3 bucket, and we have got our work group created and also set as the work group for query execution. Now I need to create a table. So I'm simply going to create a table. I'll just copy paste code here, and here you can see it says create table users, where I'm keeping my user ID, which is integer type, my username, which is string type, and suppose this is a gaming user, and how much credit they have, I'm putting some credit information as well, which is double type. And then this is my S3 bucket location, as I showed you, and then I'm putting just two table properties. One is necessary and mandatory, which is table type equal to Iceberg. That is how you tell that your table is Iceberg table. And then I'm simply putting format is equal to Parquet, which is optional, but I just put it over here. So I run this query, and this should create my table. So yeah, you can see my table has been created. I can go to, in fact, Glue console, and I can see my table there as well. If you open this table, you can see classification is unknown. So yeah, it's because Athena created it, and it's a special table type. One thing important here, guys, you can see here that it has created the schema, and this table type is Iceberg. That's how you know this is a Iceberg table. And this, look at this location. It says under my user data, there is a metadata folder, and then we have got a JSON metadata file. So this is the metadata file, a manifest file, which actually you can use to see if you go on. If you go to, like, for instance, S3 bucket here, and if I refresh it, you got metadata. And then under the data, you have got this JSON file. This JSON file actually at this point of time has information like schema information, your partition information, which is none, because I did not use any partition. It also have got information. Also has got information like what is the data location, okay? And as we create more data, update more data, what will happen that this manifest will grow. And yeah, so it's worth watching. If you're like playing for the first time, you might want to open and see, okay, what information is now. Then you change some data and come back and see how manifest has changed, how metadata has changed. That will be very interesting to understand how behind the scene this whole feature works. So now I have got my table created, and right now I have got no data in my table. So if I go over here and say, okay, let me do here, say select star from users. Actually, yeah, it should be empty because, yeah, of course, there is no data in the table right now. Okay, so what I'm going to do now is that I'm going to create some data. So let me first create a simple record, a single record. So I'll use this one for select star only. I go to the second one, second query tab, and simply say insert into users value 1, user 1, and create of 100. Yeah, 100. Okay, and simply I run it. So what it's going to do is going to insert a single record into my table. Okay. And in fact, I can see that from here. If I simply make a query, I can see my data. Yeah, you can see here my data is there. Now let's go and see behind the scene. So if I go to my user console here and I refresh it, you can see a new data folder has been created. And if you open the metadata, you will see actually that, yeah, it does says in the metadata that it's going to use user data as a location for your data. So if I go inside this, since I did not use any partitioning information, it is doing a partitioning by its own. So simply generating some, you can say some token here under that folder. Then it gets one more folder, and then under that you have a user data folder, and here is your here is your data. So if you open this one, or if you query this one, in fact, let me query this. This is the actual data. So if I come over here and say I want to query this S3 data, and this is Parquet format, but I need my output in CSV format, comma separated. If I run this query, I can see one user 1 and 100. You can see that my data is ready. So similarly, you can also inspect. I mean, it's very interesting to see and play with it a bit. So let me go back to user data folder. Let me do some more inserts. So let me insert, do a bulk insert, like for instance, something like this. So this is, I'm trying to do a bulk insert like you do in any Redshift table or so. So if I do that, yeah, it should be there anytime now. Okay, done. And then if I go to my query number 2, okay, I think we messed up. So let me say select star from users. If I run this, yeah, I should be able to see, yeah, total 5, 6 rows, yeah, 7 rows, in fact, for all my table created. Now, if I go back to my here, this is my data folder again, and if I go to, for instance, metadata, you can see now more and more information is available because as you created the table, then you inserted 1 record, now you inserted 6 more records. It is creating your snapshot information, and your metadata, which was earlier into one file only, now it has evolved because this information is used to go back to a time travel based query. Okay, so you can open this file and see if you want to play a little more about how it's working. But if I go to my data size, I can see now I've got one more folder created. One more folder created, and my new data has gone to that particular folder. So internally, as I mentioned, since I did not provided any partition information, it's simply creating its own partition. But if you provide a column as a partition, like in your when you created a table, if you provide a column as a partition configuration, that it's simply partition data based on that particular column. In fact, that's what I will recommend you to do. Okay. So let's try to do a few more things. So just for the sake of saying, let's see if I want to run a query, and let me come over here and say I want to run a query, and I want to change my user ID 1 credit to 0. So right now my user ID 1 credit is actually, yeah, I think if I can go to 2, my user 1 credit is, where you go, yeah, is 100. I want to set it to 0. So if I simply come to my query 1 and simply run it, yeah, successful. I can come over here and, yeah, if I run this query one more time, it will show you that my user 1 credit is actually, my user 1 credit is 00 now. Similarly, you can also perform delete operation. So I can simply come over here and say I want to perform a delete operation. I want to delete a record with user ID equal to 7. I can simply do that. So that's how it works. Now let's go to a time travel query because they are very interesting ones. So for instance, if I go to this tab and say I run a query saying, okay, we perform one insert, then second insert, then one update, then one delete. Now I want to see how my data has evolved over a period of time. I can simply run query called select star from table name and then $value iceberg underscore history. If I run this, it's going to actually show me that, hey, my table has changed 4 times, and indeed it has changed 4 times. First I inserted 1 record and 6 record and 1 update and 1 delete. It shows you the snapshot IDs. It shows you what time it was modified. You can see it has been modified in quite yeah, quite fast, in fact. And it shows the snapshot for each of the version change. And for instance, this was the first one. Then the second one came. So parent is this one. Then third one came. Then parent is this one. Like this one is the parent, and that's how it shows the relationship. So if I try to make a query based on a snapshot, for instance, so I can simply come over here and I can simply say, okay, let me go to the other tab and simply say, I want to see data from the third snapshot or fourth snapshot. Let's see this one. This snapshot is, well, this is the current one, to be honest. So I can go to the first one. So, okay, let me go to the first one and simply say I want to see how was my data. Oops, I did not use my query. Copy paste oh, sorry, here we go. I can simply come over here and simply say, okay, I want to see my data out of this snapshot. So I think I need to provide a snapshot like this. If I'm not wrong, it will tell me if I'm wrong. And if I simply run it. Okay. And you can see at that point of time, you had only one record. So if you do select star at this point of time, so if I simply take out this whole thing, if I take out this whole thing to make query on the current data, it has got some 6 rows, if I'm not wrong, because one I deleted. So it has 1 to 6. But if I make query based on my snapshot, if I make query based on snapshot, which is the first entry first insert I did, you can see it shows me only one record. Similarly, you can also make a query based on your current timestamp minus interval as well. But let me show you something which is using based on certain time. So for instance, if I come over here and say, okay, I want to run based on a timestamp, and let me steal or copy this timestamp from one of my other queries. So if I come over here and say, okay, let's take the second one, and I need just till MMHSSS. Yeah, that's it. That's enough. I copy this, and if I come to my query, I replace this timestamp over here. So this is when I inserted first row and then 6 more rows. So I should see 7 rows if I'm not wrong. Hopefully. Let's see. And then if I see the outcome, yeah, I can see, oops. Okay, some mistake. Why it's showing me only one record. Okay, probably I copied the wrong row. Let me see. Okay. And let me make query. Okay, let me make query here. Okay, I could be. I might be reading this snapshot wrong, guys. So if I come over here and simply say, okay, and if I run this, yeah, I can. Oh, I can see all 7 records here, but yeah, that's all 7 records here. So you can see, probably I read timestamp in the wrong way, but yeah, you can see you can make time travel based query as well as a version based query to go and see data from one of the previous changes. So I wanted to show you all the CRUD operations, query, update, delete, and how it affects. In fact, if you want to see the fun, all the fun is happening here. If I refresh this my object table now, you can see here it has created so many snapshots, so many copies of my data, and all the information about that is available in this particular folder. You have to go through this metadata one by one to understand which is keeping what information. Actually, I have not got a chance to explore each of these files, but if you really want to see how it's tracking it under the hood, yeah, it's worth seeing that. So that was how Athena based query you can make. Now let's try to see how my client can work. So for that, I created a SageMaker notebook instance, and this notebook instance, I'm going to simply run my Athena code, and I'm going to simply query this data using, I'm simply going to query this data using the code. For that, I simply imported Boto3 library for AWS Python, and then I simply created a Athena client. So let me run this client. And of course, the role of the SageMaker notebook has access to Athena. Okay. Then I simply say I want to select star from user. So I'm getting data from the current data set. This is my database. This is my catalog. And if you want to see where the catalog was, this is what I'm talking about, the catalog, okay, data source. So come back to the client again. Then this is my work group, and then this is my output location. I run that. And then what I'm going to do, that since this whole query execution works in a asynchronous fashion, first I'm going to run start query execution, providing my query string, query, my database, catalog, my work group, all the information. Then I get a query execution ID back, and then I'm going to get status of the query, and I'll wait till the status of the query changes to succeed. And once changes to succeed, I'm simply going to show the result. Yeah, that's what I'm going to do. And for getting the result, I simply call another method called get query results. So very straightforward. First, I'm using start query execution to run the query execution. That I'm using get query execution to get the status of the query. I'm waiting till the status changes to succeed. And then once it succeeds, I make another query call, another API call get query results to get the result of the query. So let me run this. It's going to take a couple of seconds, but then it will show you the output in a JSON format. So output should be there. Yeah, here we go. Here we got the output. You can see here I've got my user ID, your username, and then these are the data columns, and these are the first row, which is header, and then we have got the value rows, so 1, user 1, 0.0, and then 2, and that's how you can see the all the 6 rows available at this point of time in the data. So that's pretty much how you can use your API calls to make a call to the data. And this API call again can be used either in any kind of ETL jobs, or it can also be used in your application to manipulate the data. So that's pretty much what I wanted to cover today, guys. And I hope you like the video. And if you like the video, please click on the like button. Please subscribe to my channel. I always look forward to your feedback, whether it is for any new content, or you want to correct me for some of my videos, some of my information I provided, or if you want to discuss any of the architecture or design things related to AWS. Please feel free to write your comments to my YouTube channel, and I will be happy to have communication with you. I plan to come back again in a week's time with another such video. In the meantime, please stay safe and have a nice day. Bye-bye.